This week's week 1 tutorial is going to be on solving algebraic inequalities. Our first problem here says to solve the following inequality for P, write your answer in simplest form. And let's go ahead and start with a little bit of discussion here. What are we trying to find out? Well, what we're trying to find out is what values of P would give me a true statement if I were to plug them into this expression. For example, is it possible that P could be 0? Well, if P is 0, then I would have 8 times 0, which is 0. And 0 minus 2 is -2. So I would have a -2 on the left side. And again, if P is equal to 0, then that would, on the right side, that would give me 10 times 0, which is 0. And then 0 minus 3 is -3. If P is 0, that would give me the statement -2 is greater than or equal to -3, which is true. But are there any other values for P that I could plug in and still get a true statement? That's what we're looking for here. In order to determine that, we use algebra and go step by step to arrive at our conclusion. So let's see what they did here. The first thing they chose to do is they chose to look at the number of terms. We have 2 terms. Remember, terms are separated by pluses and minuses. So I have 2 terms on the left side, and I have 2 terms on the right side. And our goal is to get the variable on one side and reduce the number of terms on one side. So what they chose to do is they chose to subtract 10p on the right side, and they chose to subtract the same thing on the left side. Once you subtract 10p on the right side, these are going to zero out, and that will leave you a -3 on the right side. And then on the left side, you're going to have 8p minus 10p, which is -2p, and then just bring down the -2. So what have we accomplished by doing that? Well, we've gone from 2 terms on the right side down to 1 term, and that's a good thing. And we've also ensured that the variable P is now located on one side of the inequality. From here, they just added 2 to both sides. And once they added 2 to both sides, the -2, the +2 would zero out. That would leave you -2p is greater than or equal to -1. And they got the -1 by simply adding 2 to -3. -3 plus 2, again, is -1. Now, at this point, in order to get P by itself, since we are multiplying P by -2, we would have to do the opposite operation, which is division. And after we divide both sides by -2, notice that we are left with 1p, which is what we were looking for. And then on the right side, we would divide -1 by -2. And you may recall from high school or maybe some other college math courses you've had that anytime you divide a negative by a negative, you get a positive result. So -1 divided by -2 is +1/2. One thing that I want to caution you about here when working with inequalities is this. Anytime you multiply or divide by a negative number, you are going to have to reduce the direction of the inequality sign. So notice that in this step here, we had a greater than or equal to symbol, but once we divided by -2, the symbol changed directions so that the solution reads properly. And that solution would be P is any number less than or equal to 1/2. Earlier at the beginning of the video, I plugged in 0 for P and we got a true statement. And the reason 0 works is because 0 is indeed less than or equal to 1/2. Here we have another problem. This one says solve the following inequality for C. Write your answer in simplest form. Now this one is going to be a little more complex than the previous problem, but we will go through it line by line, following our steps using algebra, and hopefully we can get to the desired result here. Notice that this time our inequality is greater than, And all it is really saying at this point is whatever we have on the left side must always be greater than what we have on the right side. And we want to know what values of C can we substitute into this expression so that it is true. That's what we're looking for. Again, we're just going to use algebra and go from there. The first thing they did was they collected like terms on the right side. In other words, if you take 6C and subtract 2C, then you get 4C. And then they just brought the plus 1 down here. Notice that so far they haven't done anything on the left side. They just brought that down. Now, some of you may be a little more savvy than others, and that's certainly fine. Some people like to do multiple things in one step. But what I'm going to try to do is I'm going to try to show a step-by-step procedure. Okay, at this point, what they decided to do was to go ahead and distribute on the left side. Now, remember that technically we have an understood 1 here in front of the parentheses. So let's not forget that as we distribute. We're going to have negative 7C. Then we take negative 1 times 8C. That gives us negative 8C. And then we distribute the negative 1 times the negative 9. That gives us a positive 9. And then again, like before, except this time we're working with the left side, we just bring down the right side. Once we do that, we can combine some like terms here. Notice that negative 7C minus 8C is negative 15C. We just bring down the plus 9. And then on the right side, we decided to go ahead and subtract a 4C from both sides. And once we subtract 4C from both sides, that gives us negative 19C plus 9. And since we subtracted 4C from both sides, that's going to leave us with the positive 1 on the right side of the inequality. And at this point, we will subtract 9 from both sides, leaving us negative 19C is greater than negative 1. And we got the negative 1 by adding these two numbers here, or in this case, subtracting negative 9 from positive 1. And finally, in order to get C by itself, notice that we have C multiplied by negative 19. We need to get rid of that negative 19. We would like to have a 1 in front of the C so that it reads C is greater than or less than something. So let's go ahead and proceed. If we divide both sides by negative 19, notice on the left side that the negative 19s cancel, which does leave me with that 1C that we were looking for. And if we divide the right side by negative 19, that takes us to this step. But remember, a negative divided by a negative is a positive. So negative 18 divided by negative 19 is actually positive 8/19. And again, since we did divide by a negative number, the negative 19 here, we went from a greater than expression to a less than expression. And let's take a look at one more problem. This one is going to involve fractions. And the key here is to do something to eliminate fractions as soon as possible. And unfortunately, in this example, it's going to take a while to do that. So let's follow through and see what they did here. This is going to be the original problem, of course. And the first thing they decided to do was to clear out the parentheses, which is always a good step if you can. And what they did was they just took this negative 1 here, multiplied by 3x. That gave them the negative 3x. And then they multiplied the negative 1 times positive 1, which is negative 1. And then they simply brought down the rest of the expression. If you look on the right side, they found that negative 3x minus 1/2 x is 7/2 x, or negative 7/2 x actually. Then they brought down the negative 1, and then they added 7/2 x to both sides. Once they did that, that left them with 1/2 x is greater than or equal to negative 1. Now they decided in this step to go ahead and actually eliminate the fraction. So they multiplied both sides by 2. And once they did that, that left them with negative 1 times 2. Notice that the final answer is x is greater than or equal to -1/2. I personally do not like the way they solved this, and you may have detected a little hesitation on my part. Let me go back and show you what I would have done to solve this. And my writing instrument is not as good as I wish it were, but I'm going to try to walk you through this. I'm going to draw slow here so it doesn't get too crazy. But I like to get rid of those fractions as soon as possible. Okay. I apologize for the time it's taking. I just want to make sure that you all can read my writing here. So let's go back and assume that this, this is where we start. And again, I like to get rid of fractions very quickly. So what I'm going to do is I'm going to do something different. I'm going to multiply this term by 2. And if I multiply that term by 2, I must multiply everything by 2. Every term gets multiplied by 2. And once I do that, on the left side, I will have 2 times -3x, which is -6x, is greater than or equal to. And then I'm going to distribute this -2 across here and here. -2 times 3x is -6x. And then the -2 times the +1 will be -2. And now for the sole reason of my actually multiplying by 2 is to get rid of this fraction over here. And once I do that, then all I have left is -x. Now, if my denominator had been, say, 7, then I would have multiplied everything by 7, and I would have still had the cancellation there, which would have left me without a fraction to deal with. At this point, it's just a matter of algebra. I'm going to combine like terms here on the right side. And if I combine like terms on the right side, I'm going to have -6x minus 1x, which is -7x, minus 2. And on the left side, I still have the -6x. And now I'm going to add 7x to both sides. If I add 7x on the right side there, then that's going to cancel away and leave me with just a -2. And if I add 7x over here on the left side, that's going to give me -6x plus 7x, which is 1x. I don't know about you, everybody has a different way of solving these things, but again, I like to get rid of the fraction in the first step, if at all possible. So study both methods, find the one that suits you best, and use that one. Thank you.